So now let me give you a more formal definition of the dot product. So let's say u and v be vectors in Rn, and let's say u is let's say u1, u2, un, and let's say v be v1, v2, vn. Then the dot product of u and v, and which is denoted by u dot v, it's equal to u1 times v1 plus u2 times v2 plus dot 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 un times vn. So the dot product is obtained by multiplying the first element of u with the first element of v and adding it to the product of the second element of u and the second element of v, and so on and so forth. So let's take an actual example. So let's say u is equal to 1, 4, 5. And let's say v is equal to 0, 2, minus 1. Then the dot product of u and v will be 1 into 0 plus 4 into 2 plus 5 into minus 1, and this will be 3. So we have learned that the cosine of angle between two unit vectors in R2 is u dot v. So now let's say u and v belong to R2. Then the cosine of the angle, which let's say theta, cosine of the angle, let's say cosine of theta will be u dot v. Okay. So let me draw these two vectors. So let's say this is u and this is v. So there's a question that you might have, is that which angle are we talking about? Are we talking about this angle, or are we talking about this angle, right? And by agreement we consider the angle between vectors to be in the range of 0 to pi. So it will be this angle theta, and theta has to be in the range of 0 to pi. All right. But what if the vectors u and v, they are in R2, but they are not unit vectors, right? So how do we find the angle between u and v now? And note that the angle between two vectors has got nothing to do with the length of the vectors, right? So the angle theta between vectors u and v will remain the same if vector u is scaled by, let's say, some scalar c, right? So you can convert vector u and v into unit vectors by multiplying them with a scalar which is the inverse of their length. So this scalar times vector u and this scalar, which is the length of vector v, times vector v, will convert these two vectors into unit vectors, right? And now let's say theta be the angle between u and v. So we know from our last lecture that cosine of theta can be represented by u1 by, so let me write it down. So this unit vector with and the dot product of this unit vector, right? And this basically expands to u dot v can also be written as the length of u multiplied by the length of v multiplied by the cosine of the angle between the two vectors. So while we have proved this result only for R2, but this holds true for any vector in any Euclidean space. So let's say u and v be vectors in Rn now, all right, and let's have an angle theta between them. Then u dot v will still be equal to length of u multiplied by length of v multiplied by cos theta, where theta is the angle between u and v. So let's take an example to make things more clear. So let's say u is equal to 1, -1, 2, 3, and let's say v is equal to, let's say 2, 2, 3, 5, right? So u dot v will be equal to 1 into 2 minus 1 into 2 plus 2 into 3 plus 3 into 5, right? And this will be 21. And the length of the vector u will be square root of 1 square plus -1 square plus 2 square plus 3 square, right? And this will be, I hope so, this will be root of 15. And length of the vector v will be equal to square root of 2 square plus 2 square plus 3 square plus 5 square, and this will be square root of 42. All right, so the angle theta between the two vectors u and v will be cos of theta will be u dot v, that is dot product of u and v, divided by the lengths or product of the lengths of u and v. Okay, and this value will be 21 divided by square root 15 and square root 42. Okay, and if you take the so basically theta will be nothing but the cos inverse of this value, 21 by root 15 root 42.